Okay, I am conscious that we are running slightly behind time, so I will cut my presentation down slightly so we get an opportunity to have that interactive session at the end with the panel. But to quickly introduce myself, my name is Joshua Davies. I'm part of the Digital Campus Innovations team at the University West of England. I've done a similar presentation to this in the past, but there are a few new slides in there, so apologies if you've actually seen it before. I'm looking at some back there. But I will skip through some of them just because we need to make sure we have time for networking, etc. at the end. But as vice chair of this group, I feel like my presentation needs to start with why we're actually here, and let's not lose sight of the overall goal. And yes, BIM is great, but it needs to serve a purpose. And sometimes I see in the industry it's not necessarily for the university industry because we're quite engaged in it, but the schools, the primary schools, this kind of thing, because of the BIM mandate, clients who don't know anything about BIM are asking for it, and they're spending a lot of money for the sake of spending money. And with difficult times fast approaching, ignoring the word BIM, basically, I think that the industry itself needs to become more efficient. That is the only way we're really going to survive moving forward, and be basically proactive and try and allow the success of this sector, which I think is one of the best in the UK, to continue. And the biggest challenge for us is simply budget and funding. Now, we're potentially facing the biggest challenge we've ever faced in the university sector at the moment, and that is going to be reduced funding in time. We still need to provide that high quality learning environment for all of our students. But with reduced funding, how are we going to do that? And just to prove that it is actually a real risk, here's some headlines from December and January and November, etc. on the BBC, that tuition fees heading down in 2019, they look like they are going to be. There's nothing set in stone yet, but it looks like they're going to be enforced by the government. Yet the government aren't going to be giving us any extra funds. And tuition fees are potentially going to be cut £6,500 based on probably an average university student fee of about £9,000 to £9,500. So that's a big difference when you're considering the amount of university students you have. And there's lots of different answers. I'm not saying we have the answer to every single one. You know, there's others that have nothing to do with facilities management or managing the estate at all. But we are looking to provide the answer to at least one, and that's basically improving the efficiency and the running of our estate. And how are we intending to do that? I think BIM is the way of doing it, but we have to remember that BIM needs to be making the process more efficient, okay? And that can allow for savings and day-to-day running costs. That's what I think BIM can really impact. If we can save on day-to-day running costs, in turn this means more money will be available to our university because we're not spending it on that day-to-day running, which means we can invest that in the future. We continue to supply them with a brand new faculty of business and law building like the University West of England have recently done, rather than running at poor productivity. We have to remember the industry challenge. I'm sure most of you have seen this. I'll say this one quickly. But the construction industry, the blue line at the bottom there, hasn't had probably a percentage of growth since 1994. You compare that to manufacturing, which has had a 3% increase per year in productivity. The construction industry alone, this is actually the American comparison, is about 10 trillion per year we spend, which is a huge part. It's about 1/7 of the economic climate within any country. Yet the productivity is completely stagnant. We haven't made it any better whatsoever. That £10 trillion, imagine if we managed to save 1/7 of that. That's a huge amount of money that we can put in more investment and secure the future of this country and the university sector itself. And we're intending to do it, once again, by tackling productivity during the CapEx and OpEx phase of existing projects and new projects for the use of BIM. Some of the ways we can do that, which we're tackling as part of this group, is the systems and information integration, asset information management, behavioural change and organisational change. If we can tackle those, I really do think we can save up to about 10%. And that's basically through disruption. Everyone here is involved in disruption within the industry. Digital design, BIM, etc. wasn't a real thing 10 to 15 years ago. We're starting to disrupt the industry, and hopefully for the better. At the moment, I'm not necessarily sure it is. We're really struggling to find the figures and facts out there, the actual statistics to say that we are saving this money, but hopefully they'll come soon enough. It should do with digitising any industry. You've seen, on average, a productivity growth. We're expecting the same in construction. And here's just a little example. I'll quickly slide over this one, but some of these companies are are actually disrupting their markets, and they've really impacted well. But look at construction across the bottom. Almost all red against overall digitalisation, digital spending, digital asset stock. Look at the difference in terms of how well they're doing. So relatively high digitalisation. That turnover for ICT, media, etc. is really well. Construction, right at the bottom. Why aren't we doing it sooner? If we digitise, we should make it much more efficient. Now, just a little background going into the university now. We've got, at the University of West of England, we've got 3 main sites, plus more satellite locations, all of them in Bristol. We do have one in Gloucester, but that's a satellite location. Frenchay being our main campus. You've got Glenside, which is mainly NHS, and then Bower Ashton, which is School of Arts. We've a challenge for university itself is we've actually got loads of different building types as well. It's not just we've got 3 estates. We've got buildings of many eras. We've got the oldest, which is an 1850s building, compared to a brand new Faculty of Business and Law, which was completed in 2016. But we still got to maintain those buildings in their own way. So how are we possibly going to do that if we paint it all in one brush, which is what the construction industry's been doing in the past? We've also got lots of different types of places we need to maintain. Labs, learning, workshops, VR wind tunnels, you get the idea. There's lots of different requirements for lots of different spaces. They shouldn't have all the same brush, and BIM is the answer to actually providing what we need on a basis by basis point. Now this is going to a little bit of statistics, and it is a little bit overhead. It's not specific to UE, but the industry statistics say that this graph here is based on £1 of investment on facilities management, okay? So they reckon 13p is on premises, 7p is on residences. If we do what the mandate says, 33% life cycle saving, we could save 6.6p per pound. Same for investments in our future is currently 20%. That's basically a capital saving of 0.8p. You put those two together, the overall saving is 7.4p on the pound. Doesn't seem like a lot, but suddenly when you're spending, that's almost 10%. When you're spending £20 million a year maintaining your estate, whatever it is, that could be £2 million a year that you're potentially saving. Well, that's £2 million more investment per year to build a new building, to provide students with what they need, to invest in something else. That is where the gap is going to be made up from the reduced funding, potentially. Apologies about the error there, but our digital ambition, so as a university, the top one says location. What we really want for the BIM agenda is to have a digital representation of every single asset. That's not to say we want all the information against every asset, we just want it digitally represented so we know it's there. Assets and quantities, basically, we're talking about there. Our ambition is to see UE lead the industry challenge. I know that Rob said something similar about his university. We're intended to do the same. Not saying we are, but any university is going to say that. Consistency, UE will practice what we teach and teach what we practice. So we're talking about applying this to the education sector. Now we actually do BIM very well in the university. Why aren't we teaching it? And we actually are now. We're running a master's course. And we need to ensure that we have one single source of truth. That means all the information is located in one spot. We're not having loads of different silos, which is too hard to manage, which is how it's been done traditionally. And then collaboration. BIM has to ensure that it has a maximum reach, hence why we're having this event today. Now, talking a little bit about our digital campus, we've got 4 main stages. Some of you are familiar with the process that we're having here. We've got graphics, data, sensors, and people, all those parts that we need to tackle to ensure that we have a successful BIM campus and digital campus itself. And when I say graphics, what I'm trying to say there is that we need to understand how models can be linked to CAFM. What's the point in having graphics if we're not doing anything with them? We need to put processes into place to extract the data from the models, use the models for future operations of the estate, so verified current information, and understand the reliability of models. Now that's a really difficult one, and I'll run into that a little bit now as well. With graphics identification, the University of West of England, we've got about 30 different models, but they've all got different levels of data. Some of them were handed over to us 7 years ago when we had no data requirement. Others have been laser scanned, so they're really, really useful. We know exactly how they are. And the way we've actually started to manage that process itself, understand what's important within a model, what's not, we've inputted something or created something called a level of validity or verification scale against those different assets in the model, which we apply as a parameter. And what that allows us to do is identify on a day-to-day running basis with our works contractors. They have access to the models, which I'll run through again later. They have access to the model. We highlight something in the CAFM system, it's saying this needs replacing that smoke detector, it's faulty. They can then look into our models, click on the items within the actual cloud platform and have a look at that smoke detector. It's got a certain amount of list against it and it's got a location, but we don't know if that smoke detector is actually there because we haven't got round to completing all of those models fully accurately yet. So we've given it an LOV. If it's in a building that we haven't surveyed, we haven't 3D scanned, we don't know it's there, it's going to have a low LEV, which basically tells the works contractor that they need to do some site investigation before they even think about repairing that device. Whereas if we've actually laser scanned it, we know it's there, we know what type it is, we know what manufacturer it is, they can use a spare straight from the store, they know that they don't have to do any site investigation at all. Our works contractors are saying they're saving about 30 minutes a day when we've got a level of LOV of 10. When it's 1, it's back to the normal process, but at least they know where it is that what they're trying to fix. So just a little bit about our asset portfolio. We've got 22 models which we're actually using. As I said, we've got about 30 to 32, but some of them are just shell architectural models, or we need to look at them in the future. But we have all these different buildings. So this is the Hillside Gardens project, which we recently completed. I'll talk about that one later. There's the FBL building. Our block, which is the Students' Union, the Laundry Project, Arnold Feeney, which is down in the Bristol city centre. All these buildings are available on the cloud in a viewable model format, which basically allows our work contractors who don't know how to use Revit, they don't have a clue what to do in those kind of software, and we're not asking them to. We don't really want them to. But what they do need to do is view the models, because when they go out to site and make the amendments, they need to report that back to us. And we've got all these bits. So this is basically how we manage our models. Now, what's great about the Revisto platform that we're using here is they have floating licenses, and we can apply those licenses outside of the organisation. So we've got about 40 within UE, but we've also got about 30 that we hand out to our contractors on our capital projects, but also our work contractors to basically update the models, comment back, itemise what's changed. That's how we basically manage it. And there's a process for it basically. So imagine for small works, so a light bulb needs replacing on a very small scale, or a fan core unit, for example. This is the workflow. Basically, we get a request from the BMS system, the CAFM system, saying, hey, can you replace this smoke detector? That gets sent out to the contractor who carries out the work. But what we're now asking them to do, and what we've provided them with, we've given them, out of our own pocket, 8 iPads. With those 8 iPads, they have the Revisto licenses of all these different buildings, okay? They then go out on site, they make the amendment, but whilst they make the amendment, they take the iPad with them. We've given them training in this, and they do it really very well now. It took a little bit of time, and it wasn't easy, but they do it now. But they take a picture of the changes they've made, where it is, and they update us with the data. What have they replaced it with? Is it something new? Is there new data that we need to apply to it? They then upload it to Revisto, and they assign it to someone at University of West of England, usually myself, Mike, or some of our design team. And then the digital campus team, which is us ourselves, will update it in the host native model. That way it's not overcomplicated. We've got a backlog of items that are coming up within our inbox on this software of items we needed to update to make sure it's continuously updating. We have a constant reflection of reality against that model. That's how we handle small works. We update it in Revit, then that Revit with the bidirectional link that we've got with Archibus, which is our CAFM system, gets sent straight through. We do the same with spaces, and we do the same with asset data as well. So that's basically how we manage those small works, which I know was a question that came up earlier. There was a learning curve to it. I'm not saying it happened overnight. There was a little bit of resistance from our works contractors, but now it's written into their contract that they have to do it this way. And it's proven to actually go very well. And to be honest, once you give them a bunch of iPads or however many we've given them, generally they're willing to do it because they get nice kit with it as well. So maybe it's a little bit of a sweetener. When it comes to big, medium and larger projects, now I've got a question to ask the audience this, potentially at the end, we'll run by it just because we're running a little bit low on time. Is how they manage a certain part of this. So with medium and large works, medium works we usually have our own design team internally which manage the process. So a small classroom alteration, a new wall, a new door, a new window, whatever it is, I don't know. We update it in our host Revit model ourselves. When it's external, we hand them our model and we say, you need to update this. Or potentially it's a brand new model, you know, it's a new building, the engineering building going on at the moment, but it's a bit more difficult. For example, in the Bauer Ashton campus, in the building 2, which is a fairly new one, we've got a lot of fire kit being added to the models themselves. We've sent that model out to the designers so they can input the data they need to, which unfortunately means we now have a backlog of information coming up against us for the small changes made to that building. My question is, how have people managed that other than creating a backlog in the past? And we'll run through that later. But basically, the contractors installs as per the model, as you'd expect. Any site changes need to be passed back to the designer to update. So we need that written in the contract. If not, the contractor needs to take ownership of it. And then it gets handed over to us, and then we basically take it on as the as-built model again, just like we would any other project. Don't need to overcomplicate it. Now to the second part of the jigsaw puzzle. With Digital Campus, what we really need to understand is the value of data and what can it be used as within your organisation. Don't have too much, don't have too little. You need to make sure you get it right in terms of your requirements. You need to understand the value of the data within the CAFM system. Why would you ask for something that your CAFM system can't take? Put processes in place to maintain that data. That's an important one, which it always reverts back to how we maintain the graphics. And then don't create standalone silos and think of a single source of truth. Once again, we need all that data into one place. We don't want loads of different silos that don't tell us much information. And we've done it slightly different to some others. We use Uniclass 2015. We actually find it works for us. I'm not saying NRM's wrong. I'm not saying Uniclass 2015 is right. It just works for us and it works for our assistant designers. But basically what we've done is we've taken the Uniclass 2015 table based on projects that have been handed over to us over the last 5 or 6 years. So we're not using the whole Uniclass table. And we've created a hierarchy within that. So we've gone through, it was a mundane task to do it originally, but we've basically come up with a platinum, gold, silver and bronze asset list against those different assets. Now, we did it for the entire list at once, and what we've now done is condense that asset, that Uniclass 2015 list. People may say, whoa, what you're doing, you shouldn't be doing that, but we've done it because it works for us, to be honest, which means you don't get duplications across the whole field. That means that when we give a Uniclass code on a fire doors, something like that, wooden timber door sets, it's got a gold asset in terms of the hierarchy. From this table, we know that gold has to have yes for all the yellows across the bottom there. So if we're looking up here, there's asset identifier, space number, serial number, installation date, replacement cost, warranties, that kind of thing. For silver, you don't need that much data. So there you're actually prioritizing your assets against your facilities management process. We came up with this table and that hierarchy by running through with our internal team, the guys who are actually using this data to either design or maintain. We didn't come up with it ourselves because we don't know best, they do. So we spoke to our mechanical engineers, our electrical engineers, our actual architectural guys, you know, carpet, chairs, all this kind of stuff. What's actually important, what data is important to them? They told us what our primary assets, you know, our maintainable assets were, the most information they wanted. For example, the platinum. When it came across something they don't really care about, but kind of need to know it's there, it's bronze. When we don't need it, it's red. Don't give it to us, ignore it. We just won't ask for that data. So that's how we basically manage the information that comes into us. That means we don't get too much, we don't get too little, we get about the right amount. Now, I'm not saying it's completely sold at the moment and it's all fine and dandy, because sometimes there's an asset list, a classification that we don't have, which they're inputting into a new building. When they do that, we just work with them and they say, hey, we can't find anything within your list for this asset, what do you want it to give it? And then we can add it to the list. I'm not saying it's complete, it's always growing, it's always changing. Some items are being taken off, some items are being replaced. But basically the workflow for the data is pretty simple, as you'd expect. We get it down in our EAR and AIRs, designer and modelers put it in, they put it into the Revit environment. Us at UE, we've got our own validation tool. I know some people out there use Celebri, but we've actually created our own using Excel, and it works really, really well. It did take a little bit of time to create, but now it works just exactly how we need it against that Uniclass code. So if Uniclass code appears within what they've classified in the model itself, it will come up red and say, you've used a Uniclass code that we don't like. We're not using it. So please replace it or talk to us about it, and we'll see if we can add it ourselves. That goes back and forward until we get what we want. Once it's correct, we're happy, we give it the validation tick, it goes into Archibus. When it goes into Archibus, you get the plan preventive maintenance, you get the fix on fail, and then you get the sensors. Now this one is a little bit theoretical because we haven't done this yet. And once again, there's a question that I'd like to ask at the back, see if anyone has done it, and if so, how did you do it? But this is about sensors. Now, we would really like BIM to link up with sensor data. We don't know how to do it yet. We've got sensors in our BMS systems. We've got a BMS manager who's like, doesn't want us even anywhere near what he's doing with his BMS stuff. It doesn't work like that. So how do we potentially link it? Now, we've got an idea of how it should work, theoretically, but we've actually not implemented it in practice, and we really think it would be useful. So what we need to do is have an internal discussion on sensors and how it can be applied. We need to find an area sensors can add value and start a trial project. And then we need to manage the digital facilities through proactive maintenance as opposed to reactive. That's going to save you money. You're not going to have to go out for preventative maintenance, whatever it is, PPMs, on something that's going to last another 10 years. You know it's going to last another 10 years because it's not vibrating, it's not overheating, etc. That's what sensors will be able to tell you. And the way we see it working is fix on fail. It's low admin, low tech, but it's got a huge safety and business risk. If air conditioning here went off and it was 35 degrees outside, we wouldn't be able to have this event. Everyone would be sweating, it wouldn't be very nice. It could cause a business risk. If that's the case with students and we can provide them with the learning environments that they need within reason, same as heating, if it was too cold, then we are going to have to spend a lot of money. We might have to look at compensation and all those different factors that we haven't considered. Planned preventative maintenance is high admin, it's got medium technology. The safety risk and the business risk is reduced, but there's not much of a saving potential with it. You're doing, PPMs just for the sake of doing PPMs because you're worried that it might break in the future. You don't actually know anything about it. Sensor data is high admin and high tech, but the actual business risk is significantly reduced, and there's a huge saving potential. Imagine how much, you've got 20 devices you have to check every single day, but if you've got sensors against, just say almost everything, you're not going to have to do 10, 20 people out. You may only have to send the 2 people out to the ones that are showing as potential errors. So that is theoretical. And then there's people, and we're talking about us, and we're a diverse bunch. So let's make sure we're all on the same page and share information. Let's not create silos, which is once again reverting back what this group is. And then get data into the field, use it in turn, and it will improve our operations. And by doing that, it's pretty simple. All you need to do is good ideas are worth writing down. Make sure you have your documentation in place and make sure they are relevant to your university, to your estate. Make sure they're on point. Don't just grab something off the internet because, to be honest, the Birmingham City University, for example, or another university, it's fantastic for them, but it won't be very good for us. Likewise, ours won't be very good for them. It won't be good for us. But make sure, the biggest one is, and make sure they are consistent and repeatable documents, so try and have them the same across. And also make sure they're contractually enforceable, but also, if you can, developable for changing circumstances. If I've learned anything throughout the last 6 years in the BIM world, is things constantly change. And if it's not in the contract for a building that was procured 5 years ago, how on earth are you going to be able to capture those new changes or requirements that you need to satisfy the actual ISOs that are now released? And that's another example. Make sure they are adaptable. I'm going to skip over that one because I just ran through it. So all I'm going to do now is just quickly run through some projects. I'm running a little bit behind. Just examples of, I've got 2 example projects here. One that went pretty poorly, I want to give an honest account, and one that's gone really, really well, and it's actually up for award in the BIM show live next week for Best BIM Project of the Year. So the first one is the Faculty of Business and Law. We had a multidisciplinary team with a design and build contracts, and the BIM deliverables included the BEP, responsibility matrix, BIM protocol, LOD specification, COBie, and information exchanges. Notice there, we didn't have an EIR. No EIR in that project. We didn't have necessarily many requirements. It was so long ago this building was procured. It was a case of, there's a mandate in 2016 that says we need to do BIM level 2. In the contract goes, do BIM level 2. What happened? The consultant came up with all this, consultant and contractor came up with all this, and now they were contractually obliged to give us that. We paid them a lot of money for it as well. You're right by giving it one of those. And this is one of the documents, the BIM responsibilities document. And basically, documents were created, they were added to the contract, but they were not enforced and they weren't communicated. And what that meant was the project proceeded traditionally. The models weren't federated, they weren't working together. There was no clash detection because, to be honest, people weren't really aware of what they signed up to do. They were issued it, but I don't know, maybe they didn't look at it. And what that meant was the lack of collaboration in the BIM environment meant there was issue handover and operations. We're not anymore, but we were quite so long after handover still working on that BIM model. We didn't receive it for a long time. BIM replaced the asset list. We didn't have an asset list for about a year after this project completed. How on earth were we managing it? We had to send our works contractors out to do a whole new survey and try and capture the assets they could see, not let alone the ones that they couldn't see behind fixed panels, ceiling, tiles, all this kind of stuff. It costed us a lot of money. But also, there's a lot of repercussions here where the cost of construction could have been reduced had they done BIM correctly. What you can see here, annoyingly, there are plenty of examples where there's far too much material supplied. This here, on the right-hand side, I don't know if you can see it at the back, but that's an empty cable tray. You will not believe how many there is in that building. It's unbelievable, and they're all empty. So why were they put up there? I'm not entirely sure, just in case. Just in case. If that was done in a BIM environment, the electrical designers would be able to comment back to the designers, whoever it was, in their workshop and say, hey, we don't need these, let's save on this construction material and pocket a bit of profit for ourselves. And we wouldn't mind, because it's not a wasted material out there. It's better environmentally friendly if you're using less metal, all this kind of stuff. So that could have been completely void and limited wastage and construction cost itself. Maybe we could have taken some of that savings as well against that capital cost. But there's also a big cost of facilities management. As I said, we didn't have an asset list for about a year. You were expecting to see a model which matched reality. When I say at the start of this building we had no EIR, by the time it was actually coming handover, we had our full BIM agenda. We knew exactly what we wanted. So we relied on those contract documents at the start. And what that meant is we actually got a model which had loads of mistakes. Now, the architecture was pretty good, actually, because they were some of the BIM implementators, and we've actually had very little alterations on that. But the MEP side, it wasn't right. I don't think the subcontractors really knew what they were signing up to. And this is just an extract from Bristol here. And all these different colours, points here, is where there's error in the model. And that's from a manual check going through with our iPad, etc., picking up where something's wrong. So much so that it meant that we could not maintain the building due to the inaccuracy of the assets, which means we didn't have an asset list, and we've already described that. The contractor and subcontractor therefore had to resurvey the entire building and rectify the model after construction. Everyone who's been in the BIM, done BIM against existing projects or retrospectively will understand how difficult that is and how much time that will take. You do it beforehand, it's not that difficult, it's not that hard, it's really, really useful. You do it afterwards, you're going to be spending a lot of money, you're going to be spending a lot of time on trying to get it right. Lift and seeding tiles, understand what items are. If you just install it as per the design, you don't have to do any of that, you can save a lot of money. So this is just a couple of pictures of that building where they had to give us a survey of it because we didn't believe that the manual stuff was being, to be honest, nothing against the actual people we're working with now. They're very, very good, to be honest. I'm not going to name the contractor. But there's no way they'd be able to tell in the atrium space, which is 6 stories tall, where those assets are. So we needed a laser scan survey. We needed it in the plant rooms as well. You can see these pipes, they didn't quite line up with the actual pipes that are laser scanned. All this information that they've had to do retrospectively, which, to be honest, in any environment, they probably shouldn't have had to do. Now this is a different project example, it's a lot smaller, so it's not easy to compare the two, but this is our Hillside Garden project, the one that has been nominated for the BIM Show Live Award. It had a project fee of about £5 million, it's really not a lot. But we had a contractor on board who had no previous experience in BIM whatsoever. We actually began the BIM process quite late, which isn't best practice. But he took the brave step, or they took the brave step, of not novating the design team because they had no digital experience and they couldn't deliver to our BIM agenda. So they scrapped they didn't novate the design team and they came up with a brand new team who could deliver the agenda. And the best thing about this project was how honest the contractor were with us. And I'll go into that now. So documents were created, our new documents, concepts were carried through to the conclusion, designers and subcontractors using the model collaborated. So they did clash detection, they worked on a day-to-day basis, they looked at where design areas can be maximised, where efficiency can be grown. And then site issues were also captured as well, which actually ended up being a huge saving, not for us, but for the contractor. So it benefited them, and they've given us some really good quotes, for how, unfortunately I haven't included in this slide, but they've given us some really good quotes about how BIM benefited them, small contractor on a small project, which is why this project is so influential, because usually BIM is only for those projects which are £10 million plus. This is proof that it's not. So the construction saving, there's lots of faults were picked up. This is a really big one. This floodlight was actually located about there in front of this substation door. Usually that's not a big deal, right? Just move the floodlight. These floodlights were so specifically designed that if you moved one 1 meter, you'd have to redesign all 8. These floodlights were going in for fabrication a week after we picked up this error. That's about, I don't know actually how much, but I can imagine it's hundreds of thousands of pounds to replace those lights. Had it not been picked up, that would have been a very expensive cost to the contractor. And that's just by looking in a 3D environment. So that's just as you would expect. There's nothing special about that, but they did it on a small project. The maintenance savings from flying through the model in a collaboration workshop. So we have something we call CDM workshops. And we have the designers there, we have the contractor there, we have myself, the BIM team there. And then we have our stakeholders within the practice as well. So the electrical engineers, the operators, the works contractors, they all sit down together and we look through the model and see where we can pick out faults. Originally, these ducts here had no protection from people walking over them and battering them. They estimated that within a year, those ducts would be broken or something and need to be replaced. So what have they done? They basically produced these steps to go over the top. Not that difficult, but a huge saving for us in the future. At the time, it didn't cost anything to make that amendment or find that information. and the rails to protect the equipment on the left as well. It's surprising how so little can actually make such a big difference. And then what we did receive was a fully representative model which matched reality for us to use in our CAFM database, which is what we're doing now. We have data assigned in advance of the project completion, ensuring that no investigation works are required. So 2 weeks prior to handover, we had a data delivery, a data drop, which was handed on to my works contractor. They received the whole list of information, the PPMs, etc., that they needed prior to handover. So as soon as we got the building, that process was started straight away. There was no delay, there was no risk. And we've already used the workflow for updating the graphics successfully. The one I was referring to earlier with our works contractors, we've already used it successfully in here. One of the light bulbs or something wasn't quite working. We managed to get them out and fix it straight away. Once again, that meant the showers, whatever it was, could remain open for this building. The end product is, yes, a very well-defined, we got all the civil services, all the underground services within this product, and it's working really, really well. And the best thing about it, and the reason it went so well, I keep saying this, is simply because of the collaboration we got from that design team, from the contractor. The contractor have never done BIM or digital design before, so why would they want to do this? And they were honest with us about that, and that's one thing I'll say that a lot of contractors aren't. They said, we don't know what we're doing, can you help us? Can you have some time? Can we have a meeting here and there? We don't know what you mean by this, can you explain it to us? Whereas in a lot of other projects, because they're big firms, they've got a representation to uphold. They've got their high-end guys at the top, their digital innovations team, the guys that come up with their digital agenda. But they don't pass that down the line to the guys who are actually on site, the site managers. The site managers get all these documentation, they're fantastic, these contractual documentations you see, that the contractors produce, they really are. But the design manager doesn't know what he's looking at, what he has to do. So they go through the process saying, yeah, I have to do this, here we go. What went wrong on one of the other projects? And it wasn't delivered come the end of it, but we were told through the whole process it was. The reason this worked so well is because he was honest with us. Don't really know what I'm doing here, please can you help us? We were then able to give them advice based on our requirements. That's it from me. Actually, we won't do questions specific to me. If you want to ask questions, we'll do it as part of the panel. That is a link directly to my LinkedIn if anyone wants to add. But thank you very much. I think we've only got about 15 minutes.
Yes, so we've got like 15 minutes.